Hello everybody, welcome to Dr.K.Liu Maths channel. This question is from a university student who asked me how to do this question. The first part, let y equal to square root of 1 plus x over 1 minus x. Then we have to prove this differential equation. And it is obviously very easy part. We actually need to differentiate the function y, then put it into this equation and see whether it is true or not. And then for the second part, we have to use a Leibniz theorem, and I will talk to you how to do this one later. Okay, for the first part, y equal to 1 plus x over 1 minus x to the power 1 over 2. Then differentiate this dy over dx equal to 1 over 2, 1 plus x over 1 minus x, negative 1 over 2. Then differentiate inside by the chain rule. 1 over x times 1 minus 1 plus x times minus 1. Then 1 over 1 minus x all square. And change the position of this as that is negative index. Okay, then 1 minus x to the 1 over 2, 1 plus x to the power 1 over 2, 1 minus x to the power 2. Then we simplify this one, 1 minus x plus x, 1 plus x, that's 2, yes, 2. Then we cancel this 2. Finally, I got the result here. That is 1 over 1 plus x to the power 1 over 2 and 1 minus x to the power. Cancel these two index. And this is 3 over 2. And now put this one into, I call this equation is 2. Put 1 into 2. Left hand side equal to 1 minus x squared times this one. And minus y, 1 plus x, 1 over 2. That's because of minus 1. And this part can be rewritten as 1 minus x and 1 plus x. These two cancel. We have 1 plus x to the power 1 over 2. And these two also cancel because the index here is 1. This is 3 over 2. Then denominator is 1. The power for the denominator, 1 minus x is equal to 1 over 2. That is same as the y. That is 0. Therefore, we have 1 minus x squared. Y pi. Y pi, I denote this notation by y pi. This was for convenience. Okay. Then finally, now we have to differentiate this function. You can see that this we have already differentiated 1. Then this differentiate n times. Then from this one to this one, we have differentiate this n minus 1 more. Okay, then we actually, this 2. For Leibniz theorem, and for example, f is equal to f times g times this times, then the Leibniz theorem tells us that the differentiation is summation. Okay, summation. For the first part, n minus n equals 0, then the first one is differentiate. Keep it. Then g is differentiate n times plus nc1. F differentiate 1. G is n minus 1. And for the general term is ncr. F differentiate r. G is differentiate n minus r. Then until to the final term ncn. G. F, sorry. This F differentiate n times G is keep it. Okay, that is the Leibniz theorem. I think I have to reduce the size. Okay, then for this one, I'm here apply the Leibniz theorem here. The first one, 1 minus x to the power 2. Then this differential n minus 1 more. Then we have differential n. And the next part, NC1. NC0 is C1. I don't want to write anymore. NC1, and then difference this 1 more, negative 2x. Then for this one is difference n minus 2. That's y to the power. Difference y in n minus 1. The next part is NC2, negative 2 y n minus 2. Then is the all finished because the next NC3 then is 0. No longer terms here for the incoming. Then for the negative y we define n minus times. Then we have this one. Okay, after simplifying, we actually easily got this part. Okay, I try to finish the resets. One minus x squared dny dxn. This n minus 2xn 2nx and minus 1. We can combine these two. That is negative 2n minus 2nx plus 1 dn minus 1y dx n minus 1. That is second part. You can see. Oh, sorry. Because I make mistake here. Because n minus 1 times. That is n minus 1. Oh, I make a serious mistake here. But anyway, it is easy to revise this mistake. Or I just replace the n by n minus 1. Okay, then for the final part, this part, n minus 1 C2 is equal to n minus 1 times n minus 2 over 2. Then it's negative 2, and we have minus n minus 1, n minus 2, then dn minus 2y dx n minus 1 equal to 0. Then you can see that we can see that this is the final result here. Yeah, it is not difficult problem. Only you have to know how to operate the Leibniz theory. Leibniz is very important in calculus. Okay, and okay, I hope guys can enjoy this video. If you found Dr.K.Liu Maths channel is useful, please subscribe my channel. Bye.